Welcome to Maths with Bob. Today we're looking at a pretty big topic called algebra. We have a quick look at the introduction, addition, subtraction, multiplication and division. But I think the first thing to do is when you actually see a letter, A. Now there are a couple of spots which we need to be aware of. One of them is the index. Now I haven't written a 1 there, but I'm assuming it's a to the power 1. Otherwise I'd have a 2 or a 3 or a -1 or whatever, fractional. I can have fractional indexes as well. But basically, because there's nothing there, I'm assuming there's a 1. So that's a to the power 1 or index 1. There's also another spot, the front. The front here, now this is actually a spot for the coefficient of the particular term, Alright, so at this stage you can see there's nothing there. But we're assuming that there's a 1 there. So that A is, when you look at it, it looks pretty innocuous, but it actually is 1A to the power 1. There is a 1A and its only index is, its index is in fact 1. Okay, so the next thing we're going to look at is, what is the mathematics of letters? Well, how do I add letters? Can I add an A and an A? Yes, they are what's called like terms, and I can only add and subtract like terms, so I can't add or subtract terms which are not like, A plus A would be 2A, so let's actually look at, suppose let's affect its coefficient. Say I put 2 at the front, 2A, what is 2A plus A? Let's have a look, plus A. 2A plus A, well hopefully, we need, that's a 1A to the 1 and a 2A to the 1, so that would be 3A. So 2A plus an A would in fact be 3A. Let's try 2A plus 3A. What do we think? Well, they are like terms, fantastic. 2A and 3A is 5A. So as long as the terms are the same, or what we call in algebra like terms, we can actually add the terms, Now, if I actually start to change its index, let's change its index to, say 3. So now I have 2A to the power 3, or if you like, 2A cubed. Now, let's actually have a look. Can I add an A to that? No, I can't add an A to that, right? They are not like terms. Could I add an A cubed? Let's try that. Plus an A3. Yes, I could. 2A cubed and A cubed is, in fact, 3 lots of A cubed. Can I add a B to it? Say, a B. No. Well, that's obviously, hopefully, we can see that A cubed and B are not like terms. So the first thing we have to look at in the algebra of letters, or if you like, the mathematics of letters, I should say, is that what are like terms? Well, like terms, not only, the actual coefficients don't need to be the same, but the letter combination and their indexes do need to be the same. So before I can actually add, I need to have what's called, or subtract for that matter in algebra, I need what's called like terms. So let's actually just write that down, so you can only add or subtract like terms, So that's the first thing to realise. What is a like term? Well, like terms to A cubed would have to be, 2A cubed is like to another 2A cubed, but they always have to have an A3 in them, or A cubed. I can't have an A cubed B. Say, for instance, I had plus A cubed B. Now, although it's got an A cubed in it, it's got that B, which creates a new term, so it's not like. So you've got to be a little bit aware that, in fact, the only way I can actually create a like term to an A cubed is, in fact, if I go something like this. If I add a 5A cubed, So if I'm changing the coefficient, you can see, I'm actually just creating what's called a like term. So once I have a letter combination, the way to create like terms from a letter combination is affecting what's called the coefficient. Only the coefficient. Okay. Now, let's actually just pause it here and we'll have a look at how we multiply and divide these letters in algebra. Okay, here we can see the index laws, and these are very important in algebra. Okay, when I'm dealing with letters, if I'm actually multiplying the same letter together, I can actually add their indexes. If I'm dividing the same letter, I subtract, and if I'm actually multiplying a letter to a power to another power, I actually need to multiply those indexes. And I'm going to actually do some examples, but the first thing to realize is that these laws don't apply to this. A to the m times b to the n. Now, I cannot add those indexes, right? I just put those two terms together. I just push them together by multiplying. So I do, to start with, need to have the bases, or if you like, the letters the same before I can add their indexes. Okay, so let's actually do some examples. Okay, so some examples of index law 1. Say, let's do start with e.g. for 1. Okay, so how a cubed times a to the power 4. Okay, that's all right. That's a 3 and 4. We add those and get a to the power 7. Okay, suppose we actually had, numbers at the front. Say I had 5. Let's actually change it now to b. 7 times 3b 5. Now, you can see here, okay, now I've changed the letters, but they're still the same, b's. But I do need to now do an extra step. I need to multiply those numbers at the front, okay. So I go 3 5s are 15, and b, okay, because they're both b's, I can now 7 and 5, add those and get 12. Okay, so let's have a look at the index law number 2. Okay, so this basically says, let's start with c. So how I had c to the, say, 12 divided by, say, c to the 5. Okay, so the letters are the same. And, okay, I can just now, using index law number 2, just subtract those. And hopefully we can see that's going to be 7 to the 12 minus 5. Okay, so that's just going to be 7. Okay, so let's actually put some numbers at the front. Say I had 25d to the 11 divided by, say, 5d to the 5. Okay, so I now divide the numbers as usual by the normal division laws. I go 25 divided by 5 as applied to numbers. Okay, that would be 5. Now I have to look at the algebra law of indexes, which I need to look at. I've got the same letters. Okay, I've got a division, so I can just subtract those. Okay, so I should be able to get d to the power 11 minus 5, which should be 6. Okay, so the third index law just says if I have something to a power raised to another power, I need to multiply the powers. So let's actually have a quick look at e.g. 3. Say I had CDE, e cubed to the power, say, 5. Well, 3 5s, 15, okay. So I end up getting e to the 15. Suppose I had a number in there. So I had, say, like 3f to the 7 cubed. Okay. Well, I need to actually cube the number inside here as well. Okay, so I need to 3 times 3 times 3. Let's have a look. That's 27. Okay, I need to get 27. Okay, via the normal number rules. And now I go into what's called the algebra or letter rules, or index laws. The index law number 3 we're going to apply now. F to the 7 cubed. So I need to multiply those two indexes together and get, what's that? F to the power 3 7s, 21. Okay. Well, we'll stop there for today, and thank you for watching. We'll go on to some more algebra shortly. Bye for now.